Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Moore's Algebra 2 class. Today we're going to talk about rate of change or slope. It's really the same thing. You may be asking, okay, what is rate of change or slope? Let's think of a ski slope, guys. If you've ever gone skiing or you've heard people have gone skiing or snowboarding, they say they're going to go hit the slopes. And the reason they say that is because a mountain, okay, has what's called a slope. A slope or a rate of change is the ratio of the vertical change over the horizontal change. Okay, the vertical change over the horizontal change. So if you've ever been skiing, they have different categories of these ski runs or these ski slopes. They have black diamond, double diamond, red diamond. I'm not a big skier, but I do know that there's different categories. And those different categories are based on the slope. So what they do is they calculate, okay, how far down do I have to go and across to get from the starting point to this point? And then how far down do I have to go and how far to the right do I go to get to this point? When they calculate this, guys, they create pretty much a line. That line is based upon the slope, the change in the vertical distance over the horizontal distance. Depending on the value of this slope allows them to determine the kind of category that they give you. So a rate of change or slope, again, is the ratio, it's a fraction, of the vertical change, that's the change in the dependent variable, because that's the y, over the horizontal change, which is the change in the independent variable, which is the x. The only difference between slope and rate of change, though, guys, is that rate of change involves units. When we're actually dealing with units, feet, seconds, miles, time, units, we're talking about a rate of change. But the formula is the same. And what is the formula? Well, slope equals a rise over run or a fall over run. It depends whether it's positive or negative. If you have a positive slope, that means you are going to rise. You're going to go up and then you're going to run. If you have a negative slope, that means you're going to fall and then you're going to run. Okay? The actual formula for this slope is represented by a lowercase m. And the slope equals the y2 minus y1 over x2 minus x1. You rise, remember, if the slope is positive. You fall if the slope is negative. But no matter what, you're always running to the right, unless you go backwards, and we'll talk about that in the Chapter 2 add-on notes. But slope is y2 minus y1 over x2 minus x1. Yes, sir. Okay. We're going to go over that in the Chapter 2 add-on notes, but just for giggles, check it out. Remember how we talked about yesterday, guys, that we can graph without making a table, right? I promise you I'm going to go into this in detail, but check it out. My y-intercept here is 3. 1, 2, 3. My slope is 2/5. I'm going to rise 2 up 1, 2 over 1, 2, 3, 4. Rise 2, 1, 2 over 1, 2, 3, 4, 5. Rise 2, 1, 2 over 1, 2, 3, 4, 5. But I want to go backwards now to get the negative side of the graph, so I would go down 1, 2 over 1, 2, 3, 4, 5. Down 1, 2 over 1, 2, 3, 4, 5. And that's why I would go backwards, sir. Does that help, sir? Thank you very much, sir. Yes, sir. Okay, guys, we're going to go over this section next class. So I'm not going to start teaching this right now because we're going to do it in the Chapter 2 add-on. Okay? Thank you for your curiosity, though, but we'll get to it, guys. Let me focus now on slope, please. Okay, so, again, slope is the rise over run or fall over run, and it's y2 minus y1 divided by x2 minus x1. If it's positive, you're rising. If it's negative, you're falling. And you always run to the right unless going backwards. When you're dealing with slope or rate of change in a particular line, that slope is constant throughout the whole entire line or equation or function. It's constant. It will not change. Think about a staircase at a house. In the staircase, you see it, and every rise and run is equal, right? You have your stairs. They created these stairs based on a line. They created that line based on a slope. It must be constant throughout the whole entire line. That's why you will never graph a line that looks like this, because that would not be a constant slope. That's why you never see staircases like this. You'll never see a staircase like this. Right? Yeah, it's making some of you laugh. Yeah, that's ridiculous. You're not going to see that. Why? Because it's based on a slope. It's based on an equation, on a line. And every individual line has its own slope, and that slope is continuous throughout that line. Okay, does that make sense so far, brothers? Okay. Now, okay, let's find the rate of change here, guys. Why rate of change, Moro, and not slope? Well, please remember that the rate of change is the same as slope, except it includes units of measurement. So, whenever we have units of measurement, we must determine who the x is and who the y is. The x, remember, is independent. Time is always independent. And the distance of this particular situation is dependent on how much time has passed, so y is distance. If you want to be good at slope, I suggest you start being good at labeling. Label, 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 label. x1, y1, x2, y2. Let's find my rate of change. y2 minus y1 over x2 minus x1. This equals 260 feet every 1 minute. What on earth does this mean, though, Mr. Morrow? That means that in this particular situation, you are increasing 260 feet every single minute. So after 10 minutes, how far up would you be? 2,600 feet. Very good. Does that make sense, guys? That's what slope or rate of change tells you. It tells you your vertical change over your horizontal change. If I give you units like I very well did here, remember, we're still finding slope, but it's technically a rate of change because I must include the units. If you do not include the units in a rate of change, unfortunately it is half wrong because you have not included the units. Sir. Yes, sir. Okay, I give you guys easy numbers to teach the concept, okay? I know that it's very difficult, guys, to sometimes do the steps, especially when there's easy numbers. There's always someone that's going to say, oh, sir, but I can figure that out. Okay, I'm going to prove to you that you cannot figure it out always in your head, okay? First, let me do this. Remember always to find the independent dependent variables first, which we did. Label your x1, y1, x2, y2, which we did. And then in this case, x is time, distance is y. So again, we have the formula, which I already figured out for you. Remember, the slope or rate of change is constant throughout its own linear equation. Now, if it was something nice and easy like this, yes, almost anyone can figure that out. But what if I were to do this to you? Let's say this is x in minutes, and this is y, let's say yards, and then I give you And I want to find the rate of change. Can you do it in your head real quick? Okay, the answer is no, guys. I'm not trying to make fun of you guys. I'm trying to prove a point. I teach it with easy numbers so you can learn the procedure. That way, if it's easy numbers, great. God bless you. You can figure it out nice and easy. If it's a little bit more challenging like this, still great. You can figure it out nice and easy if you follow the procedures. So this would be x1, y1, x2, y2, y2 minus y1 over x2 minus x1. This will be 6.4 over 1.6. Wow, and I did not know it was going to work out so beautifully. This is actually pretty awesome. So this, when you divide this, it comes out to be 4 yards every 1 minute. Do you see what I'm saying now, Papa? Promise? Not always are things going to be super duper easy, where you could just look and blink and get the answer. I'm going to make it challenging. So that is why I teach the way I do. I teach the formulas and then I show you how it worked with easy numbers. You practice that procedure, and no matter what, if it's easy or difficult, you're going to be able to figure it out. Thank you for your honesty, sir. May I continue? Okay. There are 4 kinds of slope, guys. 4 kinds of slope. Positive slope. Positive slopes occur when you are increasing from left to right. You always read graphs like you read a book in English language. Left to right. Left to right. So from left to right, I am increasing. So that's a positive slope. Negative slopes go down from left to right. They go down from left to right. Think of a positive slope, you climbing up a mountain. And the negative slope, you coming down the mountain. A zero slope occurs when you have a horizontal line. Now, I'm going to do a little add-on onto this. Do you guys remember from Algebra 1 what kind of an equation gives you a horizontal line? Yes, sir. Okay. Yes, sir. No. Yes, sir. No. Yes, sir. Okay. No. The answer is no, you don't remember. That's fine. That's what I'm here for. Yes, sir? Yes. Good job. This is a y equals equation, guys. And I need you to understand this because I'm going to complicate this very much so as we continue in this chapter. When I have a zero slope comes from the equation y equals a, where a equals any real number. So in this particular case, this graph is going through 1, 2, 3, 4. This 1, 2, 3, 4. This is 4. So this equation would be y equals 4. When I have a y equals equation, I have a zero slope. If I have a zero slope, it was produced from a y equals equation. Remember that, guys. The slope of a horizontal line is 0. The equation of a horizontal line is y equals the value that it's going through. Notice that in a horizontal line, when the slope is 0, I never touch the x-axis. I'm only going through the y-axis. Conversely, undefined slope is rendered from a vertical line. And a vertical line comes from the equation x equals a. Very good. Where a is any real number. So this particular equation here would be 1, 2, 3, 4. This equation would be x equals 5. So let's make sure we're clear with this. A vertical line has an undefined slope. An undefined slope comes from an x equals equation. If you notice, a vertical line never goes to the y-axis. That's why it's undefined. So a horizontal line comes from a y equals a equation. Slope is 0. A vertical line comes from an x equals 5 equation, and it's undefined slope. Does that make sense? Okay. So those are the 4 types of slope you can have, gentlemen. Now, sometimes I'm going to give you points, and you have to actually determine the slope from the given line. You could do 2 things here. You can go ahead and find the actual points. For example, this is -1, -2, -1, and this is 1, 1. You could plug it into the formula and solve. That's fine. Or you could recognize that graphs are read from left to right. And slope is my vertical change over my horizontal change. So you can go from one perfect point to the next and find your slope very easily. For example, in this particular situation, I'm going up 1, 2, that's my vertical change, over 1, 2, 3. That's my horizontal change. My slope here is 2/3. I know I'm accurate because the line is going up from left to right, so it has to be positive. From this perfect point to this perfect point, I went up 2 over 3. Now, sometimes my students say, Mr. Moore, how do you know that that is the quote-unquote perfect point? Let me show you. What happens is this. I'm sure you guys have played those really awesome killing games. And when you're going to kill something with a sniper shot, you have to put their head in between the crosshairs, correct? Well, see where that green point is right here? Let me move it down a little bit. See where that green point is right there? Isn't that the right in the middle of the crosshairs? Those are the perfect points. That's how you can tell what the perfect point is. Does that make sense? You sure? Okay. So, in this particular case, that's a perfect point right in the middle of the crosshairs. That's a perfect point right in the middle of the crosshairs. I want to find what the slope is here. First of all, it's going down from left to right, so you know it's going to be a negative slope. What is the exact slope, though? Well, I went down 1, 2, 3, 4. So I went down 4 over 1, 2, 3, 4, 5. So my slope here is -4/5. I went down 4, run to the right 5. And that will be constant the whole entire line. Yes, sir, my brother. Okay, great question. Sometimes the fraction will be an improper fraction. You'll have a larger numerator and denominator. You can always reduce it to lowest terms, but you never turn a slope into a decimal, and you never turn a slope into a mixed number. Because if you do, you don't have a rise and a run anymore. Yeah, if it was 4/8, it'd be 1/2. You always simplify, listen to what I said. You always simplify to lowest terms, but you never turn into a decimal, and you never turn into a mixed number. Sir, my brother. So if you get a slope of 2 over 8, you simplify it to 1 over 8? Okay, no, if it was a slope of 2 over 8, you would simplify it to 1 over 4. Yeah, you always reduce to lowest terms. So that means there's going to be a point when you go down 1 to the right. Correct, sir. Yes, sir. Oh, okay. Thank you. All right. Next. What would this slope here be? Well, I've got this perfect point here, and I got this perfect point here. So very good, my brother. I'm going down 1, 2, 3 over 1, 2. So my slope here is -3/2. Do not turn it into a mixed number. Do not turn it into a decimal. You can always reduce to lowest terms, but you never turn into a mixed number or decimal. What about this bad boy? What would this slope be here? Very good, sir. I went up 1, 2 over 1, 2, 3. This slope is 2/3. Very good. Excellent. How about this bad boy right here? This is an undefined slope. Very good. Just for giggles, what would the equation of this be? X equals negative 6. Blammo. Good job, kid. Very good job. What about this bad boy over here? My slope is 0. 0 is the slope. And just for giggles, what would the equation be? Y equals negative 2. Beautimus. Sounds good. Pretty simple, right, guys? As long as you just remember to follow the procedures. Learn everything that I teach. Practice it. Yes, sir, my brother. No. The undefined slope cannot be called no slope. With all due respect, if it could be called no slope, then we would call it a no slope. But we're calling it an undefined slope. Technically, no slope would be 0, and that's a 0 slope. Please, guys, do not make up your own names for slope, please. You have 4 slopes and only 4 slopes. I'm not trying to be sarcastic. I'm trying to be honest. It's either positive, negative, undefined, or 0. If you guys put no slope, I'm going to give you no points. Okay? You will not get it right. Thank you, sir, for your honesty. Okay. So, what is the slope of the line that passes through the given points? Please remember that slope is m. m equals y2 minus y1 over x2 minus x1. Now, in this particular case, gentlemen, we actually are going to have to do the math. Okay, whoever said graph, that would take too long. You can graph each point and then graph the line and then find the rise of a run, but you're never going to finish a test or a quiz like that. So in this case, you label, 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 label. x1, y1, x2, y2. y2 minus y1 over x2 minus x1. Please notice that you're subtracting. It's x1 minus the value of x1. So I have a negative times a negative here. So this will be negative 3 over negative 2 plus 3 is 1. And that is my slope, negative 3 over 1. B, x1, y1, x2, y2. y2 minus y1 over x2 minus x1 is 0 over negative 7, which equals 0. What kind of a line would have rendered this for me? Yes, sir. Yes, 2 negatives do turn into a positive, sir. That's why you go 4 minus 7 over negative 2 plus 3. And 4 minus 7 is negative 3. And negative 2 plus 3 is 1. Thank you for verifying, sir. That's what we do to learn. Thank you. Yes, sir, my brother. I'm sorry? This is a 0 slope. It would be a y equals equation. What do you think the equation would be here, though? What's the y value that both of these points go through? So this equation would be y equals 1. Let me give you another little trick for this. Whenever you see, gentlemen, the y's of 2 points being equal, you don't have to do any calculations. You can immediately say, oh, that's a 0 slope. And how do I get the equation? It's y equals the y point that is constantly repeated. Yes, sir. Absolutely works for the same thing where the x's are equal, hence why I gave you one of these examples. The 7s of the x's are equal. So automatically, I know that this would happen. If I label it x1, y1, x2, y2, 1 minus a negative 3 over 7 minus 7 would be 4 over 0, which is undefined. You are more than welcome to do the work for that always. God bless you. That's awesome. However, if you could recognize, hey, wait a second. When the x's are the same, my slope is undefined. No, this is when the y's are the same, it's 0. That's why we put a 0 here. And then when the x's are the same, my man, we have 4 over 0, which is undefined. You cannot have 0 in the denominator. Go ahead, what's wrong? Okay, if you have a graph of this one, my brother, here's the x-axis, here's y, this is y equals 1. That gives me a 0 slope. The other one, since the x's are the same, here's 7. This is my vertical line, and that's why I have an undefined slope. The equation of this one would be x equals 7. You look confused. Talk to me, my man. That's what I'm here for. Okay, this would not be undefined, sir, because it's a horizontal line. 0 divided by negative 7 is 0. What's 4 divided by 0, though, sir? Undefined. Thank you, sir, for clarifying. Thank you. Does that make sense, gentlemen? Are you sure? Okay. For D, I got x1, y1, x2, y2. I am notorious for putting fractions on quizzes and tests. I love it. So you best know how to do it. y2 minus y1 over x2 minus x1. Common denominator here is 3, so this goes to 9. That's negative 8 thirds. Common denominator here is 5. That goes to negative 20. So that's negative 22 fifths. Stay, change, flip. Negative 8 thirds times 5 over negative 22. 4 goes into negative 8, negative 2 times. No. 4 can't do it. 2 goes into negative 8, negative 4 times. 2 goes into negative 22, negative 11 times. So I have positive 20 over 33 is my slope. You got to know how to do that, boys. Yes, sir. Okay. No. Thank you. I'm going to take my time with this then. Since you had the courage to ask, I will have the courage to be a good teacher and teach. Give me 1 second. Let me send this to a different page, okay? If you don't mind. Okay. We've gone over this before, and I've asked you guys to please learn how to add fractions. This is where sometimes you're going to run into a roadblock. If you don't do what I ask you to do, situations like this occur, and then unfortunately I have to waste the class's time now to teach you things that you should have learned 5 years ago. So I do suggest, please, that when I say learn this, learn that, learn the other, please do so on your time. But I'm going to do this one time for everyone, and then hopefully you can remember how to do it. This is x1, and again, thank you for your honesty, sir. y2 minus y1 over x2 minus x1. The common denominator between 3 and 1 here is 3. So I have to multiply 3 over 3 to this. Why? Because I want the common denominator to be 3. So this is 1/3 minus 9/3. I don't multiply anything to this guy because I already have a denominator of 3 there, my brother. So this becomes negative 8/3 over. I got negative 4 over 1 minus 2/5. I want 5 to be the common denominator, so I'm going to multiply 5 to both top and bottom. So that gives me negative 20 over 5 minus 2/5, which gives me negative 22/5. When you're dividing fractions, gentlemen, when you're dividing fractions, the first fraction stays the same. So stay, negative 8/3. Division changes to multiplication. Change. And the second fraction flips. Stay, change, flip. When you're dividing fractions, you stay, change, flip. 2 goes into negative 8, negative 4 times. 2 goes into negative 22, negative 11 times. Negative 4 times 5 is negative 20. 3 times negative 11 is negative 33. A negative times a negative is a positive. So 20 30/3. Questions? Yeah, in that case, sometimes you have to multiply both to change them. Sometimes you just have to multiply one. Thank you for your honesty, sir. Okay, last two, guys. What would the slope of E be? Undefined because the x are the same. If you want to go ahead and calculate it, that's awesome. God bless you. I suggest you learn the shortcut. Now, for a bonus, if I ask you, what's the equation? X equals 4. Very good. How about this bad boy? The slope would equal 0. What would the equation be, just for giggles? Y equals negative 3. Very good. Does that make sense, gentlemen? Any questions, gentlemen? Sure. Awesome. Thank you for a great class. I hope you learned a lot. Take care and be good. Bye-bye. Bye-bye.